Hello, everybody. My name is Abhishek Sharma. Everybody calls me Abhi. I work for LPL Financial, where I lead the technology platform from trading and investment management. The time is 2:30 p.m., also known as the post-lunch danger zone. The lunch is settling in, attention span, well, it's somewhat conflicting. So before we get started, let's get some energy in the room with some show of hand exercises. Who here is attending the reInvent conference for the first time? Wow, all right. Hopefully the experience has been good so far. It's one of the best industry conferences. Who has attended at least 5 or more times? Got some veterans in the room? Who has already done 10,000 steps today? All right, 20,000, here we come. And this is the most important question. Who has enough swags that is not gonna fit in their carry-on luggage? And is debating now, do I check in my bag? Do I buy another bag, right? Happens a lot, more than you think. On a serious note, couple of questions related to the topic at hand, which is trading platform. How many here have done any sort of stock trading in their life? Most of you guys, as expected, right? How many here understand what happens after a trade is done, after you buy and sell a security? Right. Some experts in the room as well, great. All right, so let's get to it. Before we begin the session, I want to start the session by thanking AWS. Their partnership has been truly critical in our journey. As we modernize and build the next generation trading platform, AWS provides us the tools that we need: scale, resiliency, access to the emerging AI platforms. So we appreciate the collaboration, and we look forward to make LPL the platform of choice for our advisors. So, future of trading platform. Why build a next generation trading platform? We are at the inflection point in wealth management. Speed, scale, resiliency, intelligence, those are not nice to have anymore. They are mandatory, table stakes to have any competitive advantage in the market. The next few minutes, we'll walk you through how we are designing the next-gen trading platform at LPL, a platform that is designed not just to keep up with the market, but to anticipate and adapt to it. This is the story of moving away from legacy dependencies, traditional architecture, to fully intelligent, cloud-native trading platform for the next decade. Let's get to it. So we got a jam-packed agenda today. There is no technology solution without a business problem. So we'll kick off. We'll talk a little bit more about overview of what is wealth management industry, what's happening in wealth management world, who is LPL, what is LPL's business model, zoom in to the trading platforms at LPL, what are we up to today. We'll set some context from what are the business goals, technology goals that we're trying to solve for aspirationally. We'll go through our journey in the cloud. Transformation is always a journey. It's never a big bang. We'll see how we are approaching that. We'll talk about our current state platform, our aspirational next generation architecture. And we'll go at the end with some deep dive use cases where we are applying some of the cloud principles. And it is 2025. There is no presentation worth attending without the mention of AI. So we'll talk about AI at the end. Things that we are up to and things we have aspirationally that we have in pipeline as we go. All right. And we'll save some time at Q&A. If you can't get to the Q&A, because I know everybody want to rush to the next session, so find us offline. My entire team is sitting here, so depending on the questions, we'll help do our best to answer your questions. All right, wealth management. So when we did show of hands, most of you have done some type of trading. So what is wealth management industry? At its core, wealth management is simply helping people make smart decisions with their money. How to save it, how to invest it, how to grow it, and most importantly, how to protect it. It's is the guidance given to anybody at every financial moment of their life. As an industry, wealth management is huge. 144 trillion assets under management across 300,000 financial advisors, 68 million clients. That's a big opportunity. That's a big market. And the last 2 years, especially now, is an amazing time to be in wealth management. What we call it is a generational wealth transfer is underway. What it means is there's 100 trillion assets under management, which baby boomers are transitioning these assets to the next generations. This next generation is more tech savvy, digital native. This next generation is pushing the curve. They are demanding personalization, instant responses, intelligent insights, right? Something they are very much used to from the consumer tech partners. Opportunity is huge. Challenge, how do you meet to that expectation for systems that has existed for decades? Great technology challenge, opportunity to have. Let's bring close to LPL. LPL Financial is the #1 broker-dealer in the country. We are a Fortune 500 company. What is an independent broker-dealer? Simply, independent broker-dealer is a firm that enables financial advisors to run their own business while providing the backbone they need, technology, operations, compliance, what have you. And LPL has 32,000 financial advisors. We do 2.3 trillion assets under management. What differentiates LPL from the rest of the competition is the flexibility and the scale. The ability for the financial advisors to choose technology and tools that design their own practice is amazing. This freedom of flexibility, this freedom of choice, is core to our value proposition. But from technology perspective, that it creates a great opportunity because now your platform has to adapt to small business to large-scale institutions. We are a very customer-centric organization. Our mission is to help our clients' success at every step of the way. Our vision is to be the best wealth management firm. To be the best, the technology has to be the best. It has to be adaptive, cutting edge, future ready. Let's click down within LPL. Let's talk about trading investment management. I define trading in our world as a connective tissue for financial advisors to the market. When the trade is done, behind the scene, there are hundreds of high-performance systems. They all work in unison to execute, settle a trade with the speed, accuracy, and transparency. If you look at this picture, the workflow is pretty standard. Somebody generates order is placed, it goes through process, ultimately it gets executed. While this is happening, in our world, we have 2,000 plus checks running in sub-milliseconds. And any trading system has its own complexity that's in their own ecosystem. Like in LPL, we have 70 to 80 systems that run together. But a trading system also relies on multiple partners out there, market centers, fintech organizations, right? Which makes the complexity to the next level. It's a complex ecosystem, but from a user standpoint, it should be simple and very seamless. All right. There is no technology without business objective. Tech for technology's sake doesn't really last, right? So before we define our technology, aspirational technology goals, let's bring in something that we all are comfortable with. So when we trade as a user, when you go and do a trade, what are the basic expectations when you trade? First of all, my trade should be very, very secure. No-brainer. I should be able to trade whenever I want to, always on systems. When I trade, I should get the responses instant, near real time, and it should be cheaper to do so, right? So when you look at enterprise-grade platforms like LPL, these objectives don't change. They just scale up 1,000 times over. We have to deliver on the same fundamentals as you would expect when you do a trade, but at the institutional level. Now, to define our business goals, business objectives, what are the basic business outcomes we typically expect? Customer satisfaction, in our case, advisor satisfaction, high customer retention, advisor retention. Reduce cost to serve. Ultimately, that will lead to better margin expansion. So what technology goals do we need to do to get to that? Same thing, the first one. Zero security incidents. Needless to say, wealth management is a highly regulated industry. We want to have 100% compliance into our industry. We want systems that are ultra-resilient, always on, and very fast recovery mode when the failure happens. And trading systems are designed for peak. You don't design trading system for average volume. You always design for the peak, right? So 10x scale, sub-millisecond performance, and obviously make it cheaper as you do so. Now, LPL, if you look about LPL, we are a very fast-growing organization, both organically and inorganically. As we add more advisors on the platform, those advisors will add more clients, more accounts on the platform, more trading volume. Regardless how much trading volume happens, every advisor, every client account expects speed, scale, institutional-grade resiliency. And how are we doing that? So we have two objectives to meet those expectations. First, we want to leverage AWS Cloud to provide the speed, scale, and resiliency commitment to our customers. And we want to infuse intelligence in our platform, leveraging AI, platforms like SageMaker, Bedrock, and others. The next slides, we look at exactly how we are trying to do that. So our cloud journey. The journey is a very appropriate term, especially large-scale organizations like us, right? It's never big bang to go to the cloud. So we have been on a cloud journey for a few years now, but to keep it simple, we'll anchor ourselves in 2024. To understand how we are doing our cloud journey, this is more of an iterative fashion where every year, every step feeds into the next step. It's not a migration, it's a reinvention. I had to use the word reinvention somewhere. But it truly is a reinvention every step of the way. So the way we deliberately began a cloud journey, the analogy I can give, the best analogy we can come up with is building a skyscraper. You want to get to a very fault-tolerant system, highly resilient platform. It's like building like a skyscraper. You don't start a skyscraper with the 40th floor. You build the foundation, reinforce the core. Then you add electricity, plumbing, automations, what have you. Every level helps the next level to withstand more load and grow taller and operate smarter. Our journey is very similar. Up until 2024, we started migrating more and more of our processes from our on-prem data centers to the cloud. We have multiple critical systems running in EKS, and we'll see more in some use cases. We are adopting more AI. We have machine learning algorithms which are used on SageMaker. This year has been a lot about auto-scaling. Now, one thing about auto-scaling is EKS, as we all know, scales automatically if it's set up in the right way. You got to have a good independent system. So we started decoupling our platforms this year so that we can harness auto-scaling. In some instances, we have seen 10x scale just by tweaking how we design our system. And we have a good use case to talk about that today. As we go into next year, we are in a journey of enhancing our resiliency of the platform. Like today, we are multi-availability zone, and we want to transform that to a multi-region, multi-availability zone. We'll do so by reducing our on-prem dependencies, on-prem data dependencies, We do so by incrementally first trying to go to an active-passive journey. If you have done any multi-region implementations, you realize that going from active-passive to active-active, especially for right systems, is a different ballgame. So we start with active-passive, trend towards active-active. Our target state is to be really a system that is very fault-tolerant, recovers in sub-millisecond, is using AI as a digital practice within the infrastructure itself. So this is an iterative and incremental journey we are on. So let's look at our current state architecture. Right? Like I said, we have our on-prem data center, right? And we have multi-availability zone in the cloud. Our workflows today, for many instances, designed to handshake between on-prem to the cloud. So we have a dedicated handshake, dedicated line pipe between our on-prem to the cloud, which helps reduce the latency for any of the workflows that become chatty. We try to avoid chattiness, but if there's chattiness, it reduces the latency. Some of the key components that we have in our design from Amazon AWS perspective. We use S3 bucket for our presentation layer and content rendering, very standard. We use EKS, Kubernetes, serverless design and architecture for intensive processes. In many cases, it's actually designed to auto-scale and self-heal. We're trending towards self-heal. We'll talk a little bit more about that later. When it comes to data, it's different options depending on the need. For our relational need, which is a pretty common requirement for high transaction throughput systems, we have PostgreSQL. We use DynamoDB for our document databases for mostly read use cases. We use MemoryDB for low latency, high computing in-memory processes. Kafka is a big part of our ecosystem. It serves as a big message broker. It reduces the cascading dependencies. It reduces any failures that may happen from one system to another. Around that, we use SageMaker heavily today for our machine learning algorithms and some of the AI use cases. CloudWatch is a big part of our instrumentation, along with any observability, end-to-end observability. Right, so this is our current state. Designed, it's multi-availability zone, works in tandem with on-prem, and it works for what it is now, but we are on a journey to we are transforming this into something more futuristic and ready for the next generation. So our next-gen architecture is trending. First, the biggest thing that you see here is that there is no on-prem dependency, right? Especially for what we call as tier one critical applications. When you remove the on-prem dependency, at that time, it's easier to harness the full power of the cloud. Your resiliency becomes truly from end to end. Your failovers become simpler. So we are in the journey of transforming our on-prem dependencies to the cloud. And which is an interesting thing. If you have done any of this cloud transformation from on-prem systems traditionally, the way it is not really designed for small components. You got to break down the dependencies, sequence the work. We do it in a very risk-averse, high-tested manner. We are trending towards an active multi-region environment, especially, which is going to be real, especially with reducing the on-prem dependency. And like I said, we'll start with active-passive, and we are going to trend towards active-active. One of the biggest challenges that we are seeing, and we are working on it, is how do you make sure the data is consistent for right instances on multi-region? So we're looking at Aurora DB as a big use case for us. It natively supports this. How do you orchestrate requests between multiple regions in an active-active way? So those are the problems that we are solving. In the next-gen architecture, we're also adopting Bedrock along with SageMaker. We feel Bedrock, because as we adopt more Gen AI and LLM, I think Bedrock gives us better integration into our core workflows, and there's a learning curve is slightly easier. So this is our next generation architecture that we are solving for, right? Most of it, many of it actually is underway, and we want to start getting some stuff in production early next year. Now, take a quick break, water. Let's click down a little bit in terms of some of the use cases that we are supporting today. The architecture that we looked at. Let's see some use cases in action in terms of how that cloud and this native AWS helped us get there. So ClientWorks Rebalancer. ClientWorks Rebalancer is our flagship, homegrown trading platform. This platform is designed on the principle of what we call as models-based trading. Now, what is models-based trading? Now, typically an advisor will have hundreds of clients, let's say. Each client, as you would imagine, would have different investment needs, different goals, investment objectives, risk profiles. Some clients may want an aggressive portfolio, high reward, high risk. Some may want conservative portfolio, low reward, low risk. For example, if someone is close to retirement, you may see more conservative portfolio like that. Now, advisors will typically create portfolios to meet the client's need as per their investment objectives, their goals. And that's good. But markets is always changing, right? Our market is always moving, always changing. I mean, if you think about this year, think of the big market movers this year. Interest rate changes, tariff changes, AI disruptions. Those are pretty common instances in the market. And when those swings happen, the portfolio completely deviates from what it was intended to do. A portfolio that was supposed to be conservative will become moderately aggressive. And that's not good. An advisor will have to, financial advisor in this case, will have to take prompt action to avoid any market exposure for the client. Now, without automation, this would be a very tedious manual process, account by account, client by client. Not scalable, error prone. How do we solve this? Models-based practice. In models-based practice, advisors sets up models, and each model will be flagged by metadata, like this model is for aggressive portfolio, conservative portfolio. An advisor will assign the model to the account. So ultimately, this would be a one-to-many relationship from model to accounts. So when the trading happens, advisor is not trading the account, the advisor is actually trading on the models. This principle is exactly the principle ClientWorks Rebalancer is built on. ClientWorks Rebalancer today does millions of drift checks in parallel. It does executions, trade executions automatically. It does so by being fully compliant with a seamless experience for the advisors. The best analogy I see of ClientWorks Rebalancer is like a GPS. When you put a target destination, your GPS will recalibrate, reroute based on the traffic pattern. That's exactly what ClientWorks Rebalancer does. Thousands of accounts, millions of trades, calibrated in the ClientWorks Rebalancer. As the market moves, it will suggest automatically and bring the accounts back into their original goal. Today, on ClientWorks Rebalancer, we have 14,000 advisors. And this has been a deliberate incremental journey for the last 5 years. If you recall, we have 32,000 advisors at LPL Financial. And we are slowly rolling this platform out to more and more advisors incrementally. We have done more than 70 million trades on this platform, and we do 1 million drift checks every day on this platform. So this is the product side of the equation, setting the business context. Now let's take a simple use case. One use case within ClientWorks Rebalancer, powered by AWS for hyperscaling. When a trade happens, each trade, like let's say ClientWorks Rebalancer, a trade happens, each trade will do 50 plus checks. Think about things like, what are the common things if I want to trade? Is my account okay? Account details. What is the price right now in the market? What is the licensing check? What is the compliance rules for this trade? Imagine 50 plus calls, thousands of trades across hundreds of accounts, across hundreds of advisors. We're looking at hundreds of thousands of trade volume going through every minute. The way we design the platform, so if you keep with me from the left to right, imagine a large rebalance trade comes in from the advisor. We run an orchestrator This orchestrator looks at the function and sees, how do we smartly design this hundreds of thousands of trades into chunks? So it breaks into small mini batches. All these chunks, these mini batches, go to Kafka, which is our message broker. And Kafka is amazing because it has guaranteed delivery. So it goes to Kafka. On the other side is where the brain is, the rebalancer. The rebalance algorithm is sitting on an EKS cluster, right? It's designed to auto-scale. That the algorithm of rebalancer is made in a way is completely independent of each other. It's harnessing the full power of EKS for auto-scaling. So in real time, it will look at what's my CPU right now? What is the memory utilization? What is the queue depth on my Kafka stream right now? And based on that, it will scale up or spawn more instances of rebalancer within EKS. Now, if you remember, I said something about 2,000 checks that happen. More than 200 checks from that actually are pre-trade validation. So pre-trade validation to even know if this trade can be done or not, right? And you want to do the trade checks as soon as possible. So what we do here in rebalancer is we do in-process caching of all the data and the rules for 200 plus trade checks. So instantaneously, we get sub-millisecond feedback, and the trade cannot be done, it's not in good order, failed from here, is kicked back to the queue, and will not make its way forward. All right, so we have rebalancer, EKS, auto-scaling, in-process caching for pre-trade validation. From here, there are intensive processes that happen for every trade, every rebalance. So what we did, we applied the principle of parallelization over here. So we looked at all the 60 plus microservices database calls happen. We grouped them as per the dependency map and see what can be run in parallel. So we decided we run everything in parallel, and the rebalancer calling them, and they're designed to not block each other. Now from here, every system, right, has reads and writes. Now reads has different problems, writes have different problems, right? So from here, we applied the paradigm of CQRS, command query responsibility segregation. Most of you know about that. So for the writes, we optimize the writes, writing to one server, but the writes are not transactional. The writes are batched, buffered together, so that we have less hits to the database. From here, the reads fan out, and the reads are going to the read instances because there are more reads than writes in the system. So the reads are optimized for that. And we also do a lot of caching in MemoryDB, in AWS, which helps for any computations, anything that may be intensive, we pre-calculate, get it ready in memory for further steps. Now, one thing that we are doing now is adaptive scaling on the read instances. Because this system is heavy read, so we want the system to, like I said, the EKS automatically scales, we want the reads to automatically scale. So we're doing adaptive scaling on the reads. Throughout this life cycle, we use CloudWatch to end-to-end observability. When the trade happens, from that it gets a correlation ID, because obviously we got a heavy logging, full traceability of every trade. And that trade will tell us, that token tells us how did the trade navigate, which cluster it went through, did it go through, how long did it take, so we use CloudWatch for that. We also do, now all the systems are designed to self-alert, self-heal, the EKS cluster especially, but we also do synthetics. So what synthetics, what we do? Basically, we create a transaction which mimics how an advisor would do this. So we run that transaction for end-to-end from the system just every iteratively, so that we know if there's a problem with the platform, we will know before the users knows it. Today, the system is running thousands of transactions per second. We have seen almost 1 million transactions in peak volume. And it's ready for more. All right. AI, as promised. So we'll talk about some of our use cases we are doing in AI. So our philosophy in LPL, we truly believe the power of AI, that AI is here to help advisors get smarter and more efficient. But we believe in a human-in-the-loop approach, as AI is suggesting outcomes, as AI is suggesting smart recommendations inside, advisor will still be in control. taking those insights. So let's look at the first use case. So market center outage, right? So when a trade happens, right, the trade doesn't just go and execute. There are a set of intermediaries that before it reaches the market center. Some of the intermediaries are within the company, some are external to the market. But the critical endpoint is the market center is where actually the trades happen. Now, these market centers sometimes have slowness, and there are multiple market centers, right? Not just one, there are many market centers. But sometimes there are challenges, problems, and outages even in market centers. And by the time we get alerts, it's kind of late for us to know to react to it. What happens is that there's an outage in a market center, orders keep piling on to the system. Worse, new orders keep on piling on as well. If you look at from advisor's perspective, from the user's perspective, the user would say, oh, my order did not go through. Let me try it again. Duplicates happen. Complete operational nightmare when you start getting duplicates in the system. So our goal was to left shift and know as much as we can from market center outage ahead of that. So how did we do that? So we created a workflow. Now this workflow first feeds all the real-time trades and executions to an algorithm. This algorithm detects patterns for any anomalies. And if the anomaly is detected, it will transition the anomalies and outcome to the operational team, and they will start taking actions from there. What algorithm do we use? We use an algorithm called random cut forest, which is a time series anomaly detection algorithm. That's first use case. And we'll talk about architecture after this, like how we did that using SageMaker. The second use case we have is our ETF classification. Now, obviously, in trading, there are a lot of securities. You got equities, you got mutual funds, you got ETFs, which are type of equities. Now, if you know ETFs have different holdings that go in there, right? Based on what goes in an ETF, we have to classify ETF in different categories. For example, let's say there's an ETF for crypto, ETF for commodities, ETF for foreign funds. Based on the metadata of the ETF, what it holds, we have to classify because there is a regulatory implication. Because certain ETFs, there has to be licensing checks. There has to be compliance rules. There have to be trainings that the user advisor has to go through. So this is a pretty critical workflow where we got to flag and categorize the ETF appropriately. Now, traditionally, this was done more manually, where somebody would go, look at the data, look at the prospectus, as we call it, look at the metadata for the ETF, and manually classify it. So we decided, how do we start? Because and ETF is a fast-changing market. There are new ETFs always added in the marketplace. So how do we automate that? So we created a workflow here, which runs nightly. It takes an ETFs as we goes. It runs through a model, a trained model, and that model will suggest what ETF this category should be categorized as, and the operational staff reviews and accepts it. The algorithm we used was ANN, Artificial Neural Network, which is an unsupervised model for doing so, with high accuracy. Now let's get to the architecture of how we did this. So any AI model has to be trained, right? You got to have the data, historical data, wherever you get the data, so it gets better outcome, better results. We store the data in the RDS, Aurora Postgres database. For example, the first use case, the market center outage, the data for that is all the historical trades and executions data. The data is stored over there. The second use case, which is the classification, all the security master, all the metadata around it is stored in the database. From here, we have a Lambda function. This Lambda function picks this data, historical data, which is curated, updated every day, massages it, gets it ready, dumps the data for learning in S3 bucket. And this is where the heart comes into play, which is the SageMaker. So our SageMaker is where we train and the models reside. So SageMaker, in this case, will pick up the trained data, the training data, run through it, train it, And once it's trained, it's ready to be published, and it's available as an endpoint, as a model, trained model for downstream consumption. Very simple workflow. Now, let's run these couple of use cases. The first use case in the real-time anomaly detection, right? So as the trades, hundreds and thousands of trades are going in real time, the stream of data is picked up by the Lambda on the right side. It picks up this data, runs this data via the trained model, that endpoint. Like in this case, the random cut forest algorithm. It will detect the time series data, tell us that, hey, there's an anomaly. If there's an anomaly, immediately it alerts the staff. Then the data is fed back to the RDS for future learnings based on the decisions that the model took. Same thing for the ETF classification. New ETF comes, go to the Lambda function, runs it by the trained model endpoint, gets the outcome, gives the outcome to the operator, and it's ready in the RDS instance. So yeah, so this works, and it's fully functional. It's really helped us a lot, at least these couple of use cases. So some of the use cases that we have underway right now. So the first one is a trading back office automation. Right, so this is our multi-agentic solution that we are currently, it's underway in our side. So let me give some business context to this problem that we are trying to solve here. So when we all invest money, what is our goal? Grow money, right? We want to make more money. When the portfolio grows, what happens? More capital gains taxes. The more taxes has high impact on accounts which are larger sizes. Especially for ultra-high net worth clients, the tax consequences can be huge. And there are typically tax thresholds that, hey, for this account, this is the max tax I would like to pay every year. So there are tax thresholds. Now, we saw that a rebalancer itself is a complicated process. Now, imagine a rebalancer overlaid with tax awareness, tax optimization, tax consequences, gets different level of complex. We have algorithm that takes 50 plus variables into account. Now, when we run, and each of these variables has an interdependency. If one changes, there's impact to the other one, and they're highly, highly sensitive. So tweaking those variables in the algorithm and getting the right return and the right tax outcomes, it's a very difficult process and very hard to scale. So we decided, we explored different possibilities. So one of the things that we are looking at is using a multi-agentic agentic AI framework to solve this problem. So what is an agent? As we all know, agent is nothing but a model that has a role and takes actions based on the role. So the first agent we have is a rebalancer. So this rebalancer model, this agent is trained with two data sets. First data set is the algorithm that I talked about. It is trained with that algorithm. It's trained with this 50 plus parameters, these variables, different combinations, what does each variable do. The other set of data that it is trained with is the historical runs, right? So if there was a run for a tax-aware trade rebalancer, especially which is done manually today, good outcomes, not so favorable outcomes, regardless, whatever data is, it's actually trained with that data. So imagine now, we are doing hundreds of these requests in a day. A request comes in, the rebalancer agent runs the request, gets some outcome, right? This outcome goes back. Based on the favorable outcome, it will go to the validation agent. Now, validation agent, its role is very simple. Rebalancer just looks at the rebalance as one thing. Validation looks around the ecosystem of an account, a client. Is this outcome going to create any cascading dependencies and impact? Based on that, the validation agent on a happy path will approve it, and it goes to the trading agent, which I'm dumbing down as an agent, which is more complex. But trading agent will just execute the trades with the market makers, market centers. Now, the other path where the validation agent fails, based on whatever the rule may be, it will send the response back with the appropriate feedback to the rebalancer agent so that it can reprocess this request. So it's an agentic loop, but in some of our initial studies, it has given us 10x scale already in terms of what it can do from the throughput standpoint. So we're very excited about this as an agentic AI solution. Next use case is the model suggestions for account portfolio that's being worked on right now. So we talked about models-based trading. So the industry is trended towards models-based trading. But advisors, in many cases, some part of the book is not catered towards model-based trading. Why? Historical reasons, it's very common, right? But the process to actually convert the platform or the accounts to a models-based practice or around the models is a very operationally intensive process and not really scalable. So we are working on an AI solution, and it will be very simple. It will look at advisor, the current book, and the holdings for the accounts which have models, accounts that do not have models. Based on the book, based on the accounts and the holdings, it will suggest the models that the advisor can use to transition towards models-based practice. It's a very efficiency play for the advisors over here, because we don't want advisors to spend time in operational work versus spend more time with the customers. Right, so this is our end of the presentation. This journey has been pretty fun. It's truly been a team effort for multiple teams, organizations within the company, technology, business, product, and our partners. And I want to call out Cognizant for the partnership and support during the process. Great. So I appreciate everybody coming in, and we are here if you have any questions. Find us on LinkedIn for the team, and happy to connect with you guys. Thank you so much for attending the session. Thank you.